Hello everyone, and welcome to another video from LLM 0 to 100 series. As you requested, I'm here with a video to show you how to perform RAG with various databases. But I want to take you much further than that, because RAG with databases is not the most effective way that you can interact with them and extract information from them. So I created this sub-series called Advanced RAG Series, and it is going to contain 3 videos where I will focus on RAG and Q&A with various databases, and I will show you how to convert Excel files, CSV files, SQL databases, and text files into a SQL database, a vector database, or a graph database, and use large language models to interact with them. A few days ago, I shared with you this schema on our YouTube community channel. This is a little bit modified, but I will go through all the details. So when you want to interact with your databases, there are technically 2 different ways that you can implement your project. The first one is to implement a RAG project, and the second one, as I'm calling it Q&A, is to implement a Q&A project. There is a fundamental difference between these 2. When we implement a RAG project, we have an embedding model in our pipeline that is going to convert the user's question to vectors. Then we will use that vector to perform a vector search over the content of our vector database. Then we retrieve the most relevant content and we pass it to a large language model to get the final result. And it doesn't matter if we are performing the vector search on a graph database or a vector database. But on the other side, when I talk about a Q&A pipeline, it means that I have an LLM agent that takes the user's question, but instead of converting it to vectors, it converts it to a query that our database understands. Then it uses that query on our database to get the results. Then it passes the results to a large language models and it gives us the answer. So with that explanation, you probably understood that that is going to lead to a very different performance and behavior with these 2 approaches. So when we use a RAG pipeline, we are technically looking for some sort of a semantic relationship between our question and the content of the vector database. But when we use an LLM agent, we are using the exact query that an expert would use to extract the information that we are looking from the database. So we expect to get much more accurate and precise answers from our database. And we can also ask much more complex questions from our databases. So my main goal in this sub-series is to give you all these techniques and tools that allows you to implement whichever you want based on your project's specifications and needs. So I divided these techniques into different groups. As you can see, they are distinguished using different colors. So we have the blue group, which is the one that I'm going to focus in this video. We have the green group, and the yellow one, and the purple one. So for the purple one, we already have a video on the channel, so I'm going to skip that one. It is called RAG GPT. Feel free to check it out. But in this video, I want to show you how to use SQL LLM agents and interact with SQL databases that are created from CSV files, Excel files, and SQL databases. In the next video, I will show you how to use LLM agents, knowledge graph, and graph database to interact with CSV files and Excel files. I will also show you how to perform RAG with CSV files and Excel files using graph database. And in the third video, I will show you how to use knowledge graph, LLMs, embedding models, and graph database to interact with documents. So that is going to be somehow the twin project of RAG GPT, since in RAG GPT we were also dealing with documents, but this time we are going to use knowledge graph and graph databases. And keep it in mind that knowledge graph is going to open up a whole new world for you, because knowledge graph allows you to leverage the knowledge within your database or the knowledge shared among different databases. So as soon as you are able to build and construct the knowledge graph from your databases, then you can start asking much more complex questions than you would be able to ask from a normal RAG pipeline, or in some cases from a Q&A pipeline that is directly connected to a SQL database. So knowledge graph is just, in my opinion, the next level of where this whole domain is moving toward, and it's going to address some of the most challenging tasks in the domain. For instance, in the second video, I will also show you a project from Microsoft in which they have designed a medical chatbot using a knowledge graph. So then you can start asking questions about how many patients were diagnosed with that specific issue, or these type of questions which a RAG pipeline would never be able to give you the answer for that question. So I'm going to go through these 3 projects in this sub-series. The first 2 are already uploaded on the GitHub repository, and you can go through the repository, although the repository is different from LLM 0200. I will show you quickly the repository after the presentation. And the third one, I will upload it in a couple of days. So the first project is Q&A and RAG with SQL and Tabular Data. In this project, I'm going to use Microsoft Azure. You can also use OpenAI. I will use Excel files, CSV files, and SQL data. I will also use SQLite and LangChain. So I mentioned that I'm going to use an LLM agent. The LLM agent, the SQL agent, is from LangChain. This is the schema of that agent, and this is the reference for LangChain website. Again, as you can see, the main difference between using an LLM agent to perform that Q&A that I mentioned on a SQL database versus having a RAG pipeline is between these 2 steps, embedding and vector search. We don't have it here, but instead, we pass the question to a large language model. That large language model is going to create the query, then it's going to use it on our SQL database, and then it passes the results to another large language model, and we are going to get the answer. And everything that happens here is going to happen automatically. And on top of that, if something goes wrong, for instance, if something needs to be modified in the query, the agent does it automatically for us. So it has the capability to fix itself and try again until it reaches to the proper result. To show you how to perform RAG on tabular data, I will cover 2 different techniques. In this video, I will cover the one on the top, which is to treat each row of a tabular data as a chunk of a vector database. So to give you an example, this is the dataset of the Titanic dataset from Kaggle. The first row has survived 0, P class 3, name Mr. Owen, etc. So one way to perform RAG with a tabular database is to create a string from each row. So I have a string here, which contains the column name, which is survived, with its value, which is 0. The next column name is P class, with its value, which is 3. And then we have the name, Mr. Owen, etc. through the end. Then I will store this. Then I will convert this string to vector, and I will store both this string and the vector in a vector database. So I can perform vector search on that. So in case my dataset has 30 rows, there will be 30 chunks in my vector database. This is one way to do it, and I will show you how to do it in this video. In the next video, I will show you how to perform vector search on a specific column. So if I have, for instance, a column here that is called description, and that column gives a comprehensive description of each specific row, I can only convert that specific column into vectors, and then we store the information in, for instance, in the next video, in a graph database, and we perform RAG only on that specific vector column. So these are the 2 ways that I'm going to cover RAG for tabular data. There might be other ways that you can think of, but in general, again, when you want to deal with datasets, tabular datasets, databases, etc., the best way is actually to use LLM agents to perform to query those databases using the languages that those databases understand. That would be the most effective way to interact with them. This is the schema of the project that we will develop in this video. And as you can see, I provided the description on the top here. So the red lines are the data preparation pipeline for SQL database, which allows us to perform Q&A. As you can see, our chatbot is interacting with a SQL database or with a vector database. So to create the SQL database, I can convert a SQL database, Excel file, or CSV files into a SQL database, which is the red line. I can also upload a CSV file and Excel file while using the chatbot, which automatically will be converted into a SQL database. The green lines are for data preparation pipeline for a vector database. So I will show you how to convert a CSV file or Excel file into a vector database. The yellow lines are the chat pipeline for interacting with a SQL agent and a SQL database. So as soon as the user asks a question, that question is going to be passed to a SQL agent. That agent is going to automatically generate the query, use the query on our database, get the results, pass the results to a large language model, and what we get in the output is the answer to our question. And the blue lines are the chat pipeline for interacting with the embedding model, LLM, and a vector database to perform RAG on our tabular data. So the user asks a question, we pass that question to an embedding model, we get the vectors, we perform the vector search on our vector database, we retrieve the most relevant content, we pass those contents along with the system role, along with the user's question to a large language model, and then we will get the answer from it. So now let me show you quickly the GitHub repository, the databases and datasets that I'm going to use in this project, and then we will jump on the code and we will see how this whole thing works. So this is the GitHub repository that I mentioned earlier. It is called Advanced RAG Series, so it is different from LLM 0200. As you can see, 2 projects are already uploaded. You have access to both. They are both functional, and you can immediately clone the repository and start using them. And for this project, I'm also going to use LangChain SQL agent. I showed you the link on the presentation. I will also include the link in the description, and also you can find the link in the GitHub repository README file. I will use 3 different datasets. The first one is diabetes dataset from Kaggle. The second one is breast cancer dataset from Kaggle. And finally, I'm going to use the Chinook database. I am using them because they are very well-known databases and datasets, and they are very easy to use in your project. But in general, as soon as you understand how the whole project works, it is very easy to just feed your own dataset or databases and start interacting with them. So let me open up the project. This is the project, the schema. It is exactly the same as I used to build in the previous videos, but there is one new folder here. So from this video, I decided to change the way that I explain the concepts. So first, I will go through all the knowledge that we need for implementing the project and for running the project. Then, after we understood everything, I will go through the project, the schema, and I will show you how to implement it. So during the past videos, I received a lot of questions about how I can use your projects with OpenAI models. Because as you know, I use Azure OpenAI. So I provided you with this notebook to first verify that you have the right access to your OpenAI models, GPT model and embedding model in case of this specific project. The second step is when you want to refactor the project to use OpenAI, all you need to do is first verify your connections. Second, go through the functions, like the places that I'm getting the response from one of those models. And in case it is needed to be switched to a new function, just switch the function and get the results and pass it to the rest of the pipeline, because the rest of the pipeline is going to be exactly the same for me and you if you are using OpenAI directly. The only difference would be the way that I interact with my OpenAI models versus the way that you would interact with your OpenAI models. So if I run this notebook, you can see that it is now going through GPT 3.5 and it successfully generated the response from my model, and it went through my embedding model and it successfully generated the embeddings for this single word. Another question that I received a lot is how you can pass these credentials to your project. So all you need to do is to create a .env file in your project. So I have 3, let's say, variables here. So all you need to do is just pass these variables in front of the proper names. As you can see here, I am getting the environment variable with these names. So these are the names that I'm using in my environment. And then you can easily start using the project, because it will automatically get those variables from your .env file and it's going to inject it into the project pipeline itself. So this is another question that I received a lot. I hope now you have a good understanding of how to refactor the project. Now let me go through the pipeline itself. So I have, as I showed you, 3 different types of data. I have 2 CSV files, cancer and diabetes. You can also add Excel files. The pipeline is going to automatically detect the type of your data and it's going to load it properly. I don't have an Excel file in the project, but the code is already able to handle it. Then I have the Titanic data. I have 2 versions, Titanic Small and Titanic, to show you how it works to upload a CSV file while we are using the chatbot. Then I also have the Chinook SQL data. So all you need to do is to just copy paste the information that is given on that web page that I showed you into a folder like this, and then you are good to go. You can easily convert this to a SQL database and start interacting with it. I also have this Chroma, which I will remove it here because we are going to generate it automatically. So step 1 is to prepare our SQL database and our vector database, because if you remember, in our pipeline, we had 2 different databases that would allow our chatbot to interact with them, a SQL database and a vector database. So right now I have these ones, the offline datasets and databases on top, and I need to convert them to one of these 2. So let's go through the red pipeline. And first I want to convert my SQL data, the Chinook database, to a SQL database using SQLite. So the description says to prepare the SQL database from a .sql file, copy the file into data/SQL. So I have already my folder here, and then open up a terminal. If you are using Linux, make sure that you have SQLite installed on your operating system. If you are using Windows, again, double check and make sure you have it. I already have it. So all I need to do is to create a SQL database in my data folder. So it is now going to open up a SQL database for me. In the next step, I will go through all the data in my .sql file and I will copy it in my SQL database. So this is the example that I'm going to use with the Chinook SQLite data. Here we go. So it just created this SQL database here, and it contains all the information that I'm looking for. Just to make sure that actually the information was successfully stored in my database, you can also run an example. So I know there is a table in my SQL database called artist, and if I just print the top 10 value, you will see that these are some information within that table. So now I know that my SQL database was created and it also contains the information that I'm looking for. In the next step, you need to create a SQL database from your CSV files and Excel files. So you just put your CSV files and Excel files into this folder, data/CSV underscore XLSX, and in the terminal from the project folder, execute this Python module. So I will go through the necessary information that you would need to understand how this module works. But for now, first, let's quickly create our dataset. All right, so I forgot to change the module name. Actually, it is now changed because I also added the vector database module. So in case I run this, it is going to go through my CSV and Excel files. As you can see, it detected 2 different datasets, and it's going to create a SQL database that contains all my datasets. So my SQL database right now is going to contain 2 tables, one with the name of cancer and the other one with the name of diabetes. And if I open up my data folder, you will see that a new database was created here called CSV XLSX SQL database.db. This is step 2. I just updated the file for step 3, which is to create a vector database for our CSV and Excel files. So right now, the module is pointed to this folder for upload. You can change the folder that you would like your module to point at. You can change the databases that you would like to be prepared for RAG. But right now, if I execute this code, it is going to go through Titanic Small, and it's going to create a vector database from the content of my Titanic dataset. So again, I will show you in a moment what is happening behind the scene for each one of these commands. So right now, I have my vector database, I have my CSV XLSX SQL database, and I have my SQL database from my Chinook SQL data. So that was step 1. In step 2, I want to make sure that I have the right access and connection to my SQL database. So I will quickly create a path for my SQL DB. This is going to be pointed at this one, and I will just perform a simple query, the one that we just saw on terminal, this time with another table called employee on my database. So as you can see, these are the tables that are available on my SQL database, and this is the top 10 values of that specific table itself. So again, just to avoid any confusion, make sure that you have the right access to your SQL database. In the next step, I want to start querying my database. So remember, I told you there are 2 different ways that we can interact with the database. One is using Q&A. So I want to use an LLM agent that is able to ask questions in the right way from my SQL database. The second one was to perform RAG. So I will show you how to perform RAG with a SQL database and a tabular data in a moment. But right now, let's start asking questions from our SQL databases. So I need some libraries for this task. I want SQL database from LangChain community. I'm using Piperage root for managing my directories and paths. And I'm just turning the warnings off for this notebook. I give the database folder. Again, it is sitting on my data SQL database, and I just create an instance from that database. Next, let's again verify that we have the right access to our database. Perfect. So I have the right access. I can query my database and I can get the results. So next, also, I want to make sure that I have access to my environment variables, because these are going to be used for interacting with the GPT model and our embedding model. Perfect. So the environment variables are loaded, and we now can actually read one of the environment variables for our GPT model. In the next step, let's test our GPT model. Perfect. So the GPT was able to give us the answer. I have the right connection to my model. In the next step, I want to create a SQL query chain and start interacting with my database. So to create a SQL query chain, this is where I'm creating it. I need the large language model that is going to be used in that chain, and I need my database. So we just created an instance of our database here, and I'm going to create an instance of my large language model here. So as soon as I pass those two to this function here, create SQL query chain, and I ask a question, that chain is going to give me the query that can be used on that database. So if I ask how many employees are there, it's going to look for the employees table and it's going to check the number of rows in the employees table. So this is the query that can be used on our SQL database to get the answer for this specific question. If we run that query using dbrun.response, we can see that our response is valid. It can be used for getting the results from the query. And also if we print the chain, we can see that it is giving us the system role that LangChain provided behind the scene for that chain, for that large language model. It says you are a SQLite expert, given an input question, first create a syntactically correct SQLite query to run, etc. And also it tells the agent what format to use for giving us the answer. So in the next step, I want to add one more element to the chain, which is to query the SQL database tool, because here we use the database itself, but I want the chain to be able to execute the query as well. So again, we are going to create SQL query chain with the LLM and the database. And now I will also create an instance with my database for execute query from query SQL database tool class from LangChain community. So again, in the previous step, we saw that our chain was able to give us a query, a valid query that actually can be used on our database. In this step, we just implement one more element into that chain, which is going to execute that query automatically. So if I create the chain, I will not go through the steps for creating a chain. This is how LangChain can be used for creating chains. It is a very user-friendly process. You just need to provide the steps one after another using this here. So you can see that if I ask the same question, the previous time it gave us this answer, which we then used to get the answer manually. This time it also gives us the answer. So our chain now contained two separate steps. In the next step, we create the whole chain with an LLM agent to perform the whole process for us. So it's going to go through the question, it's going to create the query, it's going to get the results, and it's going to also give us the results in a user-friendly manner. Because if I get this result just 8, it is not nice to print it like this in our chatbot. But instead, I want a user-friendly response that I can actually show to my user. So again, we are going to create the chain. We start by creating an answer prompt. We provide the structure that we want the agent to use. We create the chain from our answer prompt, the way that the query is going to be processed, and also the way that the answer is going to be processed. And then we will ask a question again. How many employees are there? So now it gave us this nice answer. There are 8 employees, and I can print it in a chatbot for my user. So this is the chain that we just created. You can go through the chain, you can modify the variables. One thing that I mentioned in the presentation is in case we use an agent, that agent is also able to fix itself if necessary. So up to this point, we were able to get the results from the database and print the answer in a nice format. But actually, if we want to implement an agent on top of this chain, we can wrap the whole process. Again, we can go through create a SQL agent. We can use an agent type. So it's going to use OpenAI LLM. We can create an agent, and then we can start asking a question. So now this time, our agent has access to a large language model, to the database, and it is also going to fix itself in case something goes wrong. So if I ask this question, you can see that the agent is now going through all the necessary steps to query our database and to give us the final output. So the input is the user's question, And the final output is the country whose customers spent the most is USA. So this is the agent that I'm going to use for our chatbot. So beside this agent, LangChain also gave us more tools to add on top of it. I'm not going to use those tools. This is just another example. Describe the playlist track table. Again, these are not the questions that you can ask from a RAG pipeline. So pay attention. List the total sales per country, which countries customers spend the most. This is not a question that you can ask from a RAG pipeline, because RAG is just going to search for the semantic relationship between the vectors created from this question with the vectors on our vector database. But now our agent is able to use a query to actually go through all the necessary steps that are needed to give us the answer for this specific question. So that was step 3. We just queried and asked questions from our SQL database, the database that was created from a SQL data itself. So this database was created from Chinook SQL database, and we were able to ask questions from it. So that was step 3. And now let's go to step 4. We also had a SQL database that was created from CSV files and Excel files. So if you remember, we had diabetes CSV files and we had the cancer CSV file. And we created a SQL database from both CSV files. So I said these two are going to be the tables in our SQL database. In step 4, I want to show you how to create this SQL database, but with another dataset, so we see the process that are needed for making that happen. To create that database, I will just load the Titanic data, so we see what we have. We have the column names, and these are the top 3 rows. To create a SQL database from the Titanic dataset, I just, again, go through SQL database from LangChain community. I also load create engine from SQL Alchemy. I create a path that I want to create that database inside it. So I will just name it test SQL database in data folder. So as soon as I run this cell, I expect a database to be added here. I create the database. I create it using create engine, and then I will just convert my data frame to my SQL database. Let's see. Here we go. We have test sqldb.db. So I just converted my Titanic data into a SQL database. And in case you want to merge multiple tables and tabular data into one SQL database, all you need to do is just to start passing those data sets into your engine and create different tables. So that is how I did it in the pipeline that I executed earlier. In that pipeline, there were 2 CSV files, and eventually we created 2 tables in our SQL data. This is how I did it in the pipeline. Next, I can start asking questions from that SQL database. So the question that I'm going to execute here is select anything from the table with the age less than 2. So I just want to have the list of the infants in the Titanic, and this is equivalent to df age less than 2 in pandas. So if I have a pandas dataset, a pandas data frame, this is how I can achieve this result. And with a SQL database, this is how I can achieve this result. And again, I can create an agent and let that agent to interact with my database. We just saw how to create an agent, and we ran the agent on the SQL database in step 3. This is going to be exactly the same. So I will load my LLM. I will create an agent with the LLM, the database, the OpenAI tools, and the web assist tool just to show us all the details. And again, a question that you cannot ask a RAG pipeline. What is the average age of survivors? So if you ask this from a RAG project, there is no way that that pipeline is going to give you the answer for that. But for this, actually our agent is now able to query the database and give us the average age of the survivors. In the meantime, while it is giving us the answer, I want to show you the equivalent in Pandas. So in Pandas, I can filter my database with survived equal to 1, means all those who survived in Titanic. I can get the age column, and I can calculate the mean value of that column, which is 28.4, and the result that the agent gives us here is the average age of the survivors is approximately 28.41 years. This is the power of using LLM agents. So that is why I told you there are much more powerful ways to interact with your databases than implementing RAG on them. So in case you would like to ask, for instance, one of the channel members asked me the other day, if I ask for what are the list of winter clothes in my database, is this pipeline able to give me the answer? Actually, to find out the proper answer, to get the proper answer for that specific question, you need to implement an LLM agent, not a RAG pipeline. So this is step 4. We just saw how to perform Q&A with a SQL database that was created from a CSV file. Now let's go to the final step, which is performing RAG with our SQL database. So let me actually bring this question because I want to show you how a RAG pipeline would fail for answering these type of questions. So the last notebook that I want to go through is going to perform RAG on our vector database. So again, I load the libraries that I require. For the vector database, I'm using ChromaDB. For the LLM, I'm using Azure OpenAI GPT 3.5. And again, make sure that you have access to your environment variables. I load the environment variables. I create an instance for my Azure OpenAI and an instance for my ChromaDB. So we just created Titanic small ChromaDB, and this is how we did it. So the first thing is to create a vector database and name the table inside that database, for instance, Titanic small in this case, because I just want the database table to have the same name as my data frame here. Then you just load the data frame that you have in mind. For instance, for simplicity, I just provided you with 5 rows for this CSV file. So in the notebook, I'm not going to go through these steps because I've already created the Chroma database from my full Titanic. But in case you just want to test, you can skip the first part that I executed this module and create the vector database from here. Then you go through each row and create exactly the structure that I told you. So each row is going to be treated as a separate chunk in my vector database. So here's the first row. I have the column name, the value, the second column name, the value, etc. And this is the second row, third row, until the rest of the CSV file. So this is one way that you can interact with your CSV and your Excel files with RAG. Then you can also inject some metadata into your vector database. For instance, for the metadata, I'm adding the name of the database itself, the dataset itself, and also you need to add some unique IDs to the vector database. So this is how you can create that vector database, and you can also count the number of values in it. So in case you go through this test here, you would have the number here, you would have 5 for the number of chunks into the database because I only loaded 5 rows. But in case you have the database ready, you can just immediately start interacting with it. So the query is, I need more info about this specific person, and I'm going to just convert the query to vector. So first, let's count the number of values in my vector database. Since I created it from the Titanic small, there are 30 rows in my dataset. And now I can perform the similarity search. So the result of the similarity search is this dictionary right here. It is not user-friendly, again, to pass this dictionary to your chatbot and to show it to your user, but instead you can pass this result along with the system role, along with the user's question. So this is exactly as I showed you here. I'm now going to pass the question, the system role, which is this one, along with the retrieved content to my large language model. Perfect. Now I have my response. I can just print the response based on the search results. Owen Harris is a male who was on board the Titanic, etc. He did not survive, and he also the chatbot is also able to give you some more information about that person. And I also printed the data frame for you here, so you can verify the answer that we just received from the RAG project. But let's change the question right now, and let's ask, what is the average age of survivors? So if you check here, the chatbot needs to filter this column and keeps only those with the value equal to 1. And then it needs to look at this column and calculates the average of that column. So if I convert this question and get the embeddings, and then perform the similarity search on the vector database and pass the results to my GPT model. And if I print the results based on the search result, we can see that the age of one of the passengers in the dataset is 39 years old. However, this information does not necessarily represent, so if I continue reading, the average age of survivors. That is when RAG falls short. And now I just hope you have a good understanding of why I don't recommend you to implement RAG with your databases, and I strongly recommend you to leverage LLM agents and to query your databases properly. It is just way more powerful than RAG. So technically, with an LLM agent, it means that you have hired an expert to interact with your database. So this was the last step. Now I want to show you how I created the project, and let's run the chatbot and see some of the questions that we just saw in the notebook again together. So to create the project, again, I have a config folder with the configs, and I just provided all the directories that my chatbot is going to look at, the stored CSV Excel files where I'm going to create my SQL databases, etc. I have my LLM config, which is the system role that I'm going to use for the agent, and also the LLM config for the system role that I'm going to use for the RAG LLM model. I have the engine for the LLM that I'm going to use, which is GPT 3.5. I have the temperature, which is equal to 0. Always use temperature equal to 0 when you are implementing a RAG pipeline or a Q&A pipeline, because you need precise answers and you don't want your model to be creative. And that's it. RAG config, I have the collection name, which is Titanic Small, because I'm going to create the vector database from Titanic Small, and I have top k equal to 1, which means after I search, the search result will only retrieve the most relevant piece of content from my vector database. I have the data folder, which we just went through. I have Explore, which we just went through. Images contain some images for the chatbot itself, and all the code for the chatbot sits here. So if you check the README file, here I provided you with all the necessary steps to execute the project. You know how to prepare the SQL database from the SQL data. You know how to prepare the SQL database from CSV files and Excel files. Here it is. So again, the third step was missing, so I just updated the README file. And you know how to prepare a vector database from your CSV and Excel files, and by For instance, right now I'm using the CSV file in for upload folder to create the vector database from Titanic Small. And finally, you can also upload a CSV file or an Excel file while using the chatbot. So I will show you how to do it while I'm using the chatbot. I've also provided you with the list of the datasets, databases, etc., and the key frameworks that I'm using here. So you have access to all the steps that you need to go through for making the chatbot functional. The first two steps that you need to take is to execute these two modules. This module is going to go through this class, prepare SQL from Tabular Data, and this module is going to execute this class, prepare vector database from Tabular Data, and also I showed you how to create a SQL database from our SQL file. So you need to execute that in the terminal. So you need to have two databases here. This test one, we just created it with the notebook, and you need to have this chroma here. So 3 databases for the chatbot to be able to interact with them. Next, you have access to app.py, which is the chatbot user interface itself. Again, it is identical to RAG GPT. I'm using these 3 functions to connect the chatbot to the backend. In respond, I'm just pointing to the right direction in my backend based on the user's question. And also, in case the user uploads a file, I'm executing this function. So I'm not going to go through the details of the backend because technically, whatever I have here is the things that I just went through in the Explore notebooks. So now let's execute our chatbot. To execute the chatbot, just simply run Python source app.py. The chatbot is running. I can bring the chatbot here. So this is the chat user interface. Again, you can type here, you can submit your text, you can upload a file, which we will see in a moment, and you can change the chatbot functionality. So in case you want to chat, just keep it on chat. In case you want to upload a file, switch it to process file and remember to switch it back to chat afterwards. Then you have the chat type. So you are able to chat with 4 different databases. The SQL database that was created from a SQL data. You can interact with a SQL database that was created from CSV and Excel files that you pre-processed in advance. You can interact with a SQL database that is going to be created as soon as you upload a CSV and Excel file. And you are able to RAG with CSV and Excel files converted into a vector database. So there are 3 Q&A and 1 RAG feature. I just put the RAG feature there so you can test and evaluate the performance. But definitely, if you are planning to interact with your databases, you can just skip this feature and make sure that your Q&A pipelines and your LLM agents are set up properly. So let's start asking questions. I also provided you with some sample questions. So to ask a question from a SQL database, again, I can ask how many employees are there. So we just got the results. There are 8 employees. And if I go back to my code, you can see the agent's steps in the terminal. So you can also go through the steps and see exactly what it is doing and just verify the process by yourself. The second question, let's again check the questions. List the total set. This is exactly the same question that we saw in the notebook. Again, the total sale amount is 523. And if you go through the terminal, you can see the performance of the agent again. One more thing about the agents, just keep it in mind. In case your agent requires to go through big chunks of data, one of the issues that you might face is the context length limits of your large language model. So I've hit the limit a few times with GPT 3.5. So I strongly recommend you to use a more powerful large language model in case, as you can see, the amount of information that is going to be processed and is going to be passed to the model sometimes gets big. So in case you would like to just make sure that your model works fine, make sure to switch to a more powerful model such as GPT-4. And in general, using GPT-4 would also make the performance smoother than 3.5. So now let's go through pre-processed databases, and let's ask what is the average single epithelial cell size in cancer data. So you remember in our SQL database that we created from CSV file, we had two different tables, cancer and diabetes. So let's ask this question. Here I switch Q&A with stored CSV XLSX SQL database. The average single epithelial cell size is 2.37. So in Explore, I also have Explore databases. You can verify the answers by checking these notebooks. So if you check cancer notebook, you see that I calculated the average using Pandas query. It is 2.36. And the result is 2.37. So it just rounded up the second decimal here. So that was one of the questions. Now let's ask another question, and this time from diabetes. So what is the average age for those who were diagnosed with diabetes? So again, same database. The average age for those who were diagnosed was 37.07. So let's go through that database. So I have a notebook here. Again, you can verify the questions. Here, this is exactly the process that happened behind that query. So our agent was able to understand that the outcome should be equal to 1, get the result of this filter, then filter based on the column name age, and finally get the average value. So as you can see, there are 3 different steps needed to get the proper answer. And the answer is 37.06, and the answer that the chatbot gave us was 37.07. Again, it rounded up the second decimal here. So we just interacted with the SQL database that was created from CSV files, Excel files, etc. Now, let's ask a question from the vector database that we created from Titanic. So if I go with RAG, and if I go into sample questions, so since that vector database was created from the same dataset, I will ask this question: what is the average age of survivors? You would see that actually it won't be able to give us the answer. Based on the search result, it seems that the average age of survivors is not provided, of course, because in RAG, it retrieved one chunk which was belonged to this person, and that chunk for sure was retrieved somehow randomly because the semantic relationship between our query and the information within our vector database just was not clear. So that is 39 years old, but it doesn't mean that the average age is 39 years old. On the other side, I can start asking questions about a specific person. So since I know this person is already there, I can say, give me more info about this person. So now this time, the system is able to retrieve the right chunk because the semantic relationship is going to find out that this person is within my dataset. Here we go. This person is a passenger in Titanic, and here is the detailed information about that person. The class level, the gender, age, etc. So we just saw the limitations of RAG with vector databases that were created from tabular data, SQL databases, etc. In the final step, I want to upload the same file, Titanic data, and ask the same question that RAG couldn't give us the answer for. So this is the dataset, and if I upload Titanic CSV, it gave me an error because I didn't change the app functionality. Again, change the app functionality before doing it. Okay, uploaded files are ready. Please ask your question. So what it did was it just automatically created a SQL database from that CSV file. And now if I switch back to chat, and if I go into Q&A with uploaded SQL database, and if I ask the same question, what is the average age of survivors? The average age of survivors is approximately 28.41. And let's verify the answer. So I go to Explore Titanic. I come down. The average age of survivors, again, it requires 3 steps to get to the answer, is 28.4. So that was the correct answer. Let's ask another question. So in sample questions, so for those who survived in Titanic, were the majority men or women? So this is the question that I want to ask. Based on the data, there were 233 female survivors and 109 male survivors. So the majority were women. All right, so let's again verify the answer. This is the answer. So it needed to first filter based on the survival equal to 1, get the sex equal to, for instance, female or male, and it's going to result in a true or false throughout those survived passengers. And then, for instance, in case of using pandas, it needed to calculate the values. So the true values are 233, which are female, and the false values, which are men, are 109. So again, the answer was correct. So we just went through all different functionalities of the chatbot. There are a few notes that I would like to go through before wrapping up the video, which are very important. One very important keynote is that when you are querying SQL databases using LLM agents, make sure not to use write privileges and limit the scope when you are allowing the users to interact with the chatbot. Because just like the user can ask for the number of, for instance, the survivors or the average age of the survivors from a dataset, a SQL database, the user can also ask to remove a database or to modify the information within that database. And the agent is actually able to generate that query, and it's going to execute that query. So in case you don't consider proper security measures, your database is going to be jeopardized, and the users can easily manipulate the dataset. So that was it for the keynote that I wanted to bring out. Again, we just designed this chatbot together. We went through all different steps of preparing the vector database and SQL database, and we started to interact with different type of datasets using our vector database and SQL database. So I hope you understand that how powerful an LLM agent can be versus a RAG project. So again, in case you are looking for proper answers and in case you would like to get accurate results from your databases, use agents. So thank you very much for watching the video, and I hope to see you in the next one.